Okay, so today we're going to talk about double angles. You guys are all very, very familiar with sine, cosine, and tangent. Okay, so sine, cosine. Let's put tangent over here. Okay, so when we first learned about sine and cosine, we learned that each of them have a period. The period for sine and cosine was 2 pi. The period for tangent was pi. And we learned that any change to what we call the argument of sine, cosine, and tangent, so if we wrote something like this, our period would change to 2 pi over 3. If we wrote something like this, our period would change to pi divided by 5. Okay, so whenever we change the period, we change the frequency of our solutions. Okay, so instead of an equation equaling 0 every 2 pi, now it equals 0 every 2 pi over 3 or every pi over 5. So generally it's considered easier to keep the original periods of sine and cosine and tangent because they're familiar. We know what we're dealing with. Okay, so that's where the double angle identities come in. Okay, so let's write those down. Okay, so sine of 2x, we have 2 sine x cosine x. Now cosine is an interesting one because there's actually 3 forms of it. So the first form we learn is cosine squared x minus sine squared x. And then there's our 2 alternative forms that look like this. 1 minus 2 sine squared x, and then 2 cosine squared x minus 1. Okay, and then we have tangent. Like that. Okay, so let's kind of practice what you're going to be doing with these. You can prove an identity, you can find an exact value, you can solve an equation. Okay, so let's talk about equations first. Okay. Okay, so let's solve the equation 2 cosine x plus sine of 2x equals 0. Okay, and we want to solve it for all x's. Okay, so we're not just going from 0 to 2 pi, we're going to solve it for all x's. Okay, so I've got, looking at this thing, I got a problem. I've got cosine, which has a period of 2 pi, and then I have sine of 2x, which has a period of pi. Okay, so, I'm going to try to make this thing a little bit easier. I want the periods to match. So we're going to look at our double angle identities. Oh, there's my one for sine. So if I do a little bit of rewriting, now all of the trig functions that I'm dealing with have a period of 2 pi. I don't have one with a period of pi and one with a period of 2 pi. The whole equation has the same period. Okay, now, So I'm looking at this thing going, oh my gosh, there are no like terms. Okay. There's nothing I can add. If I start subtracting, it gets me nowhere. I can't really divide by anything because the one thing I could divide by would be 2. Okay, so I could divide off the 2. So I get cosine x plus cosine x sine x equals 0. So now I'm looking at this thing going, oh my gosh, what do I do? So I notice that both of them have a cosine. So if I have common factor of cosine, I can actually factor that out. Like that. Okay, so when you solve a trig equation, you have to remember all of the tricks of solving equations that you've learned. You can use multiplication, division, addition, subtraction, combining like terms, factoring, finding common denominators, things like that. All of that stuff still works when you solve a trigonometric equation. It just looks different. So now, when I solve by factoring, I say each of my factors equal to 0. Okay, so now there are 2 ways I can do this. I can go ahead and use the inverse function, cosine inverse and sine inverse, okay? Or I can say, well, cosine x equals 0, that's a value on the unit circle. That's a unit circle ratio. So it asks myself, where on the unit circle does cosine equal x? Or, excuse me, equal 0? Okay, so I think about my unit circle, or I take a look at it, and I know that that happens at x equals pi over 2 and 3 pi over 2. Okay, so now, okay, I have this other equation that says 1 plus sine of x equals 0. Well, if I take that, let's draw a little arrow over here, do a little rearranging. Okay, sine of x is equal to -1, subtract the 1 from both sides, I can ask myself this question. Okay, well that happens at 3 pi over 2. Notice I have a repeat of an answer, but that's okay. Now, I also know that I want every single answer. So these answers are going to repeat over the period. So my final answer is x equals pi over 2 plus 2n pi. X equals 3 pi over 2 plus 2n pi, where n is an integer. Okay, and if you were to graph this, you would see that the repetition of the graph, and you would see the intersections, okay, or where the graph equals 0 at every 2 pi. Okay, all right, let's do another one. Let's do this one. Okay, this one is kind of complicated because if you look at it, there's a couple different ways you can go. You can replace your cosine of 2x and sine of 2x um, with their double angle identities. Um, but I'm going to not do that, okay, because I know right now the periods for both cosine of 2x and sine of 2x are equal. They're both pi, which is good. So I'm just going to leave it and I'm going to kind of play with it. So it says cosine of 2x plus sine of 2x all squared. So let's go ahead and square it. Let's see where the math takes us. Okay, now let's distribute. So cosine 2x times cosine 2x is cosine squared 2x. And then cosine 2x sine 2x plus sine 2x cosine 2x. And then sine squared 2x equals 1. All right. Looks like I've got some like terms here. All right. So now I'm going to use a strategy that some of you may not be aware of. And that is called a variable substitution. In calculus, they call it a U substitution, like the letter U. I'm going to use the variable beta. Okay, so I'm going to let beta equal 2x. Okay, so everywhere I see 2x, I'm going to replace it with beta. And by the way, this is not cheating. Okay, so the first thing I've noticed after I've replaced it is I know that cosine squared plus sine squared is equal to 1. So I'm going to replace these two with just a 1. Okay, what happens to your 1s? Well, they cancel. So I'm left with 2 cosine beta sine beta equals 0. Well, then I look at this guy, and that looks familiar too. Let's go back up here. Oh, look at that. So now 2 sine x times cosine x is sine of 2x. Well, let's see if that can help. So this gets replaced with sine 2 beta. Interesting. So if we think about it, what values does sine give you? 0. Well, that happens when the angle is 0, pi, 2 pi. That's on the unit circle, right? So my angle right here, my argument is going to be equal to now remember, beta was equal to 2x. So now I have this. So x is equal to 0. 2 times 2 is 4. So x is equal to pi over 4. 4x equals 2. Interesting. So what has happened? Okay, it looks like you're going to have solutions at 0, pi over 4, pi over 2. Where should the next one be? Okay, well, if I follow the pattern for sine, okay, my next 0 is at 3 pi. So if I solve that, I get 3 pi over 4. So every pi over 4, I'm going to have a solution. So I can write that like this. Okay. So double angles are challenging. They do take a while to get used to, but I know that you guys can do it. Okay? All right. So we'll do a couple videos on this, and I'll see you later.